So, hello and welcome to this lesson on the Simpson's 3-8 rule. So, note that in our previous videos, we've talked about the trapezium rule and the Simpson's 1/3 rule. Okay, so just a quick recap before we start this video. We said that with the trapezium rule, when you have, let's say, you are integrating this function f of x dx from a to b. If you want to use the trapezium rule, the integrand, which is f of x, we approximate it with a first order polynomial. So the first order polynomial is of the form a0 plus a1x. And you see, with a first order polynomial, we always need 2 points, a0, a1, right? Okay. And we said that with the Simpson's 1/3 rule, we approximate the integrand f of x with a second order polynomial, that is f2 of x. And with that one, we need 3 points, a0 plus a1x plus a2s squared. So as a result of that, here our least n has to be 2, because 2 segments will give us 3 points. So let's say we have this thing here. You can see here we have just one segment, so we are having 2 points. Let's say AB. If we should divide AB into two equal parts, we are going to have a certain point C here. So you see, now we'll have 2 segments, 1, 2, and we'll have 3 points. So one thing with the Simpson's 3H rule is that with that one, we approximate the integrand with a third order polynomial. Okay, so a third order polynomial means initially we need 4 points, so a0 plus a1x plus a2s squared, then plus a3s cubed. Then we needing 4 points means we have to get 3 segments. So when we have AB, to get 4 points, we have to divide this and this. So we can have a point here, C, and C, D. So you can see now we have 3 segments and we have 4 points. So that's something with what we've done so far. So already this should give you a clue about what we are coming to do. Okay, so with the Simpson's 3H rule, it is derived by approximating the integrand f of x with the third order polynomial. So since we approximate the function f of x by a cubic polynomial, say f3 of x, we always need 4 points, that is 3 segments. Okay, for the single segment Simpson's 3H rule. So I hope you get that. Okay, so let's say we have I, and I is equal to integral from a to b f of x dx, and we want to integrate this. We can approximate our integrand f of x with this third order polynomial. We will have something like this. So you see, this third order polynomial is of the form a0 x plus a1 s, no sorry, a0 plus a1x plus a2s squared plus a3s cubed. So after doing this, we can go through the process we went through to derive the trapezium rule, if you watched that video, and also derive this, but we're not going to go through the derivation in this video. So straight away I'm going to quote the formula. So the formula for the single, the single segment for the Simpson's 3H rule means we have n to be 3. I hope you get it. Is given by integral from a to b f of x ds equals 3h over 8 f of x naught plus 3f of x1 plus 3f of x2 then plus f of x3. Okay, where our h, that's the step size, is given by b minus a over 3. You know, h is given by b minus a over n, but here we said our n is what, 3. So that's why we have this thing here. Then one thing that you have to know is that the 3 over 8 here is what, the 3 over 8 that we have here is what gives it the name Simpson's 3/8 rule. Okay, so let's solve an example with it. The understanding will be clearer. So the question says the vertical distance covered by a rocket from x equals 8 to x equals 30 seconds is given by this. And the question says we should use Simpson's 3/8 rule to find the approximate value of the integral. Okay. So you know the formula is given by integral from a to b f of x dx equals 3h over 8. Then we have f of x naught, 3 plus 3f of x1 plus 3f of x2 plus f of x3, right? So that means that we need this point x naught, x1, x2, x3, these 4 points. If you're able to get them, then we can put them inside this here, because this here happens to be our integrand, right? Our integrand is f of t equals 2000 ln 140,000 all over 140,000 minus 21,000 t then minus 9.8 t. So when you get our x0, x1, x2, x3, then we'll put them inside f of t to get the functional values at those points. Then we can put them inside our formula and we evaluate to get our answer. Okay, so we need 4 points, right? That's n is 3. We need 3 segments. Okay, so that means that you see we have the interval. We know it starts from 8 and it ends at what, 30, but we need to create 2 equal points here so that we have what, 4 points but 3 segments. You could see that first segment, second segment, third segment. So how do we know the values which are supposed to be here? So we have to find our step size h, and our step size h is given by b minus a over what, n. In this case n is 3, so b minus a over 3. And you know b is the upper limit of the integral and a is the lower limit of the integral. So you can see here the upper limit is 13, so that is b. The lower limit is a, and that is 8. Okay, 8 here. So putting it inside this formula, we'll get 30 minus 8 over 3, which will give us 22 over 3. Okay, so what this means is that our x0 will be equal to a, which is 8. Then our x1 will be a plus h, and in this case it will be 8 plus 22 over 3, and I think that will give you 46 over 3. Okay, then to get our x2, it will be a plus 2h, and that will give you 8 plus twice of what, the step size, and that will give you 68 over 3. So that's what you can see here, and this is our b. Okay, so from here that means our xi is equal to a plus ih. So this will be s0, this will be x1, this will be x2, and this will be x3. So since we have the values for x0, x1, x2, and x3, we can put them inside the function to find the functional values at those points. So f of x0 to be equal to f of 8, which is this. F of x1 is f of 46 over 3, which is this. And f of x2 is f of 68 over 3, which is that. And f of x3 is f of 30, which is that. So f of 30 means you come here, and wherever you find t, you put 30 there. You're finding f of 8. Wherever you find t, you put 8 there, and that will give you the functional values at these points. So it's now that you have f of x0, f of x3, we can substitute them into the main formula and compute our integral, right? Evaluate it. So we have the integral of the whole of this being approximated using the word Simpson's 3h rule. That is given by 3h over 8. F of x0 is f of 8 because s0 is 8. Then plus 3 f of 46 over 3 plus this and plus that. So now we have to just make substitution. So h we found to be 22 over 3. F of 8 is this. F of 46 on 3 is this. This is that. And we have this here too. So making this computation is going to give us what we can see here. So that happens to be the answer. Okay, you see it's very simple. So now let's extend it to when we have more than n being more than 3. Okay, alright. So we are going to the multiple segments. So with the Simpsons 3h, we said that we need 4 points. So with a single segment, our n has to be 3. But one thing with the multiple segments is that our n has to be multiples of 3. So our n has to be 6, 9, 12, 15. So when you have something like this, then we apply the multiple segments for the Simpsons 3h rule. So we are going to get a formula for that and know how to use that. Okay. So the multiple segments for the Simpsons 3h rule. Okay. So using n, which is equal to number of equal segments, with and the with h, we can define h to be b minus a over n, where n, I said it is 6, 9, 12 going. Okay. So it says the number of segments n need to be an integer multiple of what? 3, as a single application of Simpson's 3h rule requires what? 3 segments. So if you need to apply it twice, that's if you need to apply it twice, multiple, then you need 6. If you need to apply it 3 times, then you need 9 segments. So the formula for doing that is given by what we can see here. I is equal to integral from a to b f of x ds 3h over 8 f of x naught, then plus 3 summation I starting from 1. Then from 1 we move to 4. From 4 we move to 7. So from 7 we move to what? 10 of what? F of what? xi. Then plus 3, I starting from 2, 5, 8, 11 going, right? N minus 1, then f of what? xi. Then plus 2, we are summing I starting from 3, 6, 9, f of xi. Then plus f of what? xn. Okay, so that's the formula. So for instance, when we have n to be 6, this is how this formula will be. So let's look at it. So we get I will be equal to 3h over 8 f of what? X naught. Then plus 3. So we will get f of what? X1 here. Then we get plus what? F of what? X4 here. Because that 4 is within the range. Then we'll get plus 3 f of x2. Then plus f of what? x5. Then we get 2 times f of what? x3. But I know f of x6 is f of xn, so that will be plus f of what? 6. So that's how we expand it. When n is 9, 12, you should know how to expand this. Okay, let's solve an example with it. So it says the vertical distance covered by a rocket from x equals a to x equals 30 seconds is given by, or you can see here. So it says use Simpson's 3H multiple segment rule with n equals 6 to estimate the vertical distance. Okay, so from the question, the upper limit b is 13, and the lower limit a is 8, and we have f of t to be this, right? Okay, so we have n, the number of segments, to be 6, so our step size will be b minus a over n, which will be 30 minus 8 over 6, and which evaluates to 11 over 3. So that means we have to draw an interval and partition it into what? 6 equal parts. Alright, so that's what you can see here. And with this, our SI is equal to A plus what? I what? H. So that means we want to find S naught. S naught to be A plus 0 times H, which will be A. You want to find S1. S1 will be A plus 1 times H, which is H. You want to find, let's say, S2 to be A plus twice of H. You want to find SS to be A plus 6 what? H. So if you do that, you will get these here. Okay, so this is x0, x1, x2, x3, s4, s5, and xs. So these are the values for them. So s0 is 8, x1 is 35 on 3. Let me expand for you. S2 is 46 on 3, x3 is 19, x4 is 68 on 3, x5 is 79 on 3, and xs is 30. Okay, but you know the formula is given by this, right? So applying it to our question, expanding it, we will have coming. Okay, so expanding it, applying it to our question, expanding, we will get I will be equal to 3h f of x naught, then plus 3 multiplying f of x1 plus f of x4, then plus 3 multiplying f of x3 plus f of x5, plus 2 f of x3, then plus f of x6, right? So we then have to compute these functional values. Okay, so f of x naught is this, that equals f of 8, which will give it this. So f of 8 means you go into f of t, whenever you find t, you put 8 there. Then f of x1 is this, f of x2 is this, f of x3 is this, this, and that. Okay, so the next thing we do is to come back to this formula and put them in. So doing that, so making a substitution, we'll have I will be equal to, but now h is what? 11 on 3, so you have that here, then over 8, then we put in all the values we had, the functional values we had. Okay, so after that, you use your calculator to make these computations, and you end up with this answer here. Okay, so that is it for it. Okay, so we have discussed 3 methods for numerical integration: the trapezium rule, the Simpson's 1/3, and Simpson's 3/8. So in our next series of videos, we will also discuss numerical differentiation. So we will talk about the Euler's method, the Ranjikuta second order, and the Ranjikuta fourth order. Okay. All right. Thank you very much.